All right, here's our second video in section 4.3 about polynomials. A lot of times we can simplify our polynomials by combining some of our like terms. Now remember, they're only like terms if they look exactly the same. They have to have the same variables and the same exponents. We can combine them by simply adding their coefficients or subtracting their coefficients together. We've kind of seen this before with exponents, right? Remember, all night my aunt ran mail downstairs. Remember, anytime we're adding or subtracting, we do nothing with the exponents. We just combine like terms, but they have to look exactly the same in order for them to be like terms. For example, if you look at example number 4, it asks us to add 3x cubed plus 6x cubed. As long as they have the same variable with the same exponents, they're like terms and we can combine those. Remember, we do nothing with the exponents, we just combine or add their coefficients. So 2x cubed plus 6x cubed will really be 8x cubed. Do the same thing for b. Combine all of that polynomial's like terms. I typically start with the highest exponent first, so I'm going to look for all of the x to the fourth powers. You notice here that we have a 2x to the fourth and a negative 2x to the fourth. Well, 2x to the fourth minus 2x to the fourth is really 0x to the fourth. So they kind of zero each other out. So we normally don't write 0x to the fourth, we just don't write anything. Now I'm going to go to my next highest degree. I don't see any x cubes, but I do see some x squareds. I see a 5x squared minus a 6x squared, which really gives me a 1x squared, or a negative 1x squared, I should say. Now you can put the negative 1 in front. You can write the 1 if you want to, or you can just say negative x squared, and remember it means the same thing. Now I'm going to look at my constants. I see a 7 minus 11, which gives me a negative 4. So my final answer with all of my like terms combined would be a negative x squared minus 4, or a negative 1x squared minus 4 would be the same thing. Look at C. Let's combine any of its like terms. I'm going to start with the a cubes. I see a 7a cubed and a 9a cubed. 7 plus 9 together give me what, a 16a cubed? I also see a negative 5a squared and a positive 1a squared. When I combine that, I get a negative 4a squared. An a cubed and an a squared are not the same thing. They're not like terms. They have different exponents there, so we can't combine those. So my final answer would just be a 16a cubed minus 4a cubed. We like to see our final answers in standard form with the highest exponent first, so I would prefer you write it like that, 16a cubed minus 4a squared. Look at D. D is a little bit different because we have lots of different variables. We have x's and y's with lots of different exponents there. Again, they're only like terms if they have the same exact variable with the same exact exponent. So find any like terms in this polynomial and combine them. Now be careful. I notice that I have a 3x squared y and a negative 9x squared y. They have the same exact variable with the same exact exponents. Those are like terms. So 3 minus 9 would give me a negative 6x squared y. I also see that I have an xy squared. I have a negative 4xy squared and a positive 7xy squared. They have the same variable with the same exponents. It looks really close to the other term, but they're not like terms with those other ones, so be careful. And so if I have a negative 4 plus 7, I really end up with a positive 3xy squared. Since those are not exactly the same, they are not like terms, and that would just be my final answer. Negative 6x squared y plus 3xy squared. Now, it's hard to tell which order to put this in because the variables are different and the exponents are different. So if you wrote the answer 3xy squared minus 6x squared y, I would also accept that answer. It's the same exact answer. Just be careful that your 3 stays positive and your 6 stays negative. Okay? All right, the next thing we're going to do with our polynomials is what we call evaluating. Evaluating means we're just going to substitute in a value for that specific variable and then simplify. So for example, in example number 5, if I give you this polynomial, this quadratic trinomial, look at that, it's a second degree with 3 terms, negative x squared plus 3x plus 9, if I ask you to evaluate it when x equals negative 2. What that means is we're just going to simply take out all the x's and substitute in a negative 2 instead. So wherever I see an x, I'm going to plug in a negative 2. Now the hard part here is you have to be really careful with your notation and making sure that you go step by step so you don't miss anything. So I'm going to rewrite the problem where I'm going to take out the x's and I'm going to substitute in a -2. Now, I already had a negative to begin with, so keep that there. I'm going to take out the x and I'm going to plug in a -2. So I really have a negative and then a -2 squared, because the x is the only thing that's squared in that first term, plus 3 times a -2 plus 9. Now be careful. We have to follow the correct order of operations. Remember, parentheses, exponents, multiply and divide, and then add and subtract. Remember PEMDAS, or please excuse my dear Aunt Sally. And be careful in this first term. Remember, there's an invisible 1 here, and we do not want to take the -1 and multiply it by the -2 first. We want to make sure that we follow the correct order of operations and do exponents first. So what we really need to do is make sure that we take that -2 and square it first before we combine it with the -1 in front. So what's -2 squared? -2 times -2. I ended up getting a +4. Now I can take that +4 and multiply it with the -1. So I have 4 times -1. I also have a 3 times -2, and then I have my +9 in the back. So I ended up with a -4 plus a -6 plus 9. If I have a -4 plus a -6, that really gives me a -10, correct? A -10 plus 9 gives me a final answer simplified down to -1. Evaluating just means plug it in and simplify all the way down. Just be careful with your notation and your correct order of operations. Try those few examples and let me know if you need anything.